Okay, quiz for today was to construct our three most basic graphs. If you don't know where those are, do everything it tells you to do in Canvas, and also talk to me and email me. Okay. These graphs look pretty good, but it's upside down. Oh yeah, okay. I never know what's going to happen when I shuffle. Now, okay, what I'm saying is I'm saying all 7 points of the first graph, all 5 points of the second graph, and all 6 points of the third graph, and they're all in the right place. And the halvings, when you cut the intervals in half, look pretty good. So, you know, that's what I'm looking for. Yeah. That gets a full 10 points. Okay. Oh boy. No. On the square graph, the third point and the fifth point, the ones just to the left and right of the vertex, are not in the right place. Remember, you go over 1, down 2, over 1, down 2. Matter of fact, none of the points except the ones in the corners are in the right place. Close, but not quite. Okay, so that's not good. Next time that's 0. Okay, and on the test that's 0. If they're not all in the right place, you haven't followed the procedure. Okay, now the lines are pretty good. Okay, everything looks pretty good, except the location of those points. They aren't going to work there. You're not going to learn anything from those points. This is why you have 2 days to get this right. If you don't have it right, if you haven't drawn them, and then go back and look at the way they're constructed and see that you did it that way, then you're not yet working up to the level of this course. And if you keep not working up to the level, it's not going to work out well for you. Okay, I don't mean to be threatening. You still can get this right. Everybody can get this right, because almost everybody did it right when we did it in class a week ago. And then I said, use the videos, make sure it's all correct. Okay, it's got to be perfect. That's all I accept. You're going to have a test in a couple of weeks, and they're going to have to be perfect, and that's going to be about a quarter-year test. Okay, they've got to be perfect. I don't mean your lines, they got to be reasonable. That the locations of the points and the coordinates of the points and stuff are going to have to be perfect. So I see something reasonable, but it ain't perfect. And then I see the second graph, it's perfect. See the third graph, it's perfect. Okay, so there's somebody. Okay, we've got 2 out of 3. And just trivial mistakes in the first one kept me from getting 3 out of 3. You understand what I'm emphasizing? It's got to be perfect exactly as I told you to draw it. Now I see lining looks pretty good, but I don't see the points. I don't see the points marked, and then the curve doesn't go through the points. Okay, general shape is good, but we're not hitting the points. We're close, but if you don't mark the 5, 6, or 7 points to go on the graph, that's what you use to draw the curve. Okay, you're going to miss them if you don't mark them. So I might give that one a point. Okay, because the general idea is their general shape is. Okay, that one's perfect. Oh, that's unfortunate. And that was perfect. Okay. Really screwed up the exponential. I'm sorry, that's the easiest one. And you got the hard ones. Get the easy. Okay. Okay, that's perfect enough. That's perfect. That's perfect. Okay. Now, I'm not going to go through all of these. And of course, I'm not going to point out who I'm talking about. Another perfect paper. Whoops. No. Okay. Do you understand what I'm saying? so far, except for the habit of doing things as I say they need to be done. Everybody's either on track or can easily get on track. I don't want to see any more mistakes in these graphs. Okay? You don't want me to see any more mistakes in these graphs. Because every day I get stricter, and next time I'm totally strict. One error on the whole thing makes all three of them wrong. Got it? No errors. Now I want you to go ahead and, if you haven't already, construct the square graph. Also, anytime, remember, if you need to say something, need to answer, ask a question, all I gotta do is just give me a meaningful look or say, hey, yo, whoa. Don't say anything, just make a gesture, stop the video and answer your question, right? And I'm circulating because I always circulate, spend half the class circulating. You got a question, stop me. Say, hey, I might say, okay, let me look at the rest of these. I think I see what your question is, and I'll try to address it, right? But while the camera is running, don't go jump up and down in front of it. Don't talk. Okay, here's my not all that well-drawn sketch of the basic square function. Okay. Now, on your curve, we talked about this last time, we're going to put an x-axis here, the y-axis here. Okay. I want you to estimate I'm going to use f of x notation here. Okay. Just to illustrate f of x notation, you take a value of x, f of x is just a y coordinate. Okay. So x is an x coordinate. I still got that on the screen. F of x is the corresponding y coordinate. Okay. Now, so I'm going to do these for you. Then I'm going to give you a few to do. Okay. Very simple. I'm going to estimate f of 1.5. Now, 1.5 is the x coordinate or it's a y coordinate. Show me, not saying anything, whether it's x or y. Is 1.5 an x coordinate or a y coordinate? You can do that, that's an answer. I don't. Okay. Well, function is f of x, right? X goes in these parentheses. So when I say f of 1.5, well, x has been replaced by 1.5. So 1.5 is your x coordinate. I'll say 1.5 replaces x. Equals 1.5. This tells us that we got to find x equals 1.5 on this graph, right? Tell me when I hit x equals 1.5. Remember, this is a 4 by 4 square. Okay. So just kind of raise your hand when you think I've hit 1.5. Okay, got a vote here. Here. Bunch of votes for here. I think everybody's right. Well, let's be clear. This is the y-axis. What's the value of x on the y-axis? You can show me with your fingers. 0, right? Y-axis is where x equals 0. And you always want to be aware of that because there'll be plenty of places where you need to know that. And at that point, you're reading a problem and you're stuck. Okay? If this is where the x and the y-axis cross, x and y are both 0 at the origin, right? Okay. Now, to the left of the origin, x values are negative, right? To the right of the origin, so to the right of the origin, I think somebody tried to stop me about here. Well, I've moved 1.5 units here, so that was a good thought. Okay. But we're on the negative side, so x is not going to be 1.5 there. It's actually negative 0.5, isn't it? Or negative 1/2. Okay, well, 1.5. Well, we move to the right. Okay, 4 units from here to here. So 2 of them go from here to here, and 2 of them go from here to here, right? So here, what's the x value at this point? 1. Why? Because when you construct these things, the first thing you do after you do the center line is you cut this rectangle to the right of the center line in half. And that gives you x equals 1. All right. Now, so x is a half here, x is 1 here. 1.5 is halfway between 1 and 2. So now we can pretty securely say x is about 1.5 here. And I'll draw this line as a dotted line. And I'll label it x equals 1.5. Okay. Well, a little unfortunate, but actually not that unfortunate, pretty good. Okay. Where's the point on the graph where x equals 1.5? All the points where x equals 1.5 are on this vertical line, aren't they? Okay, so tell me where to stop. A couple of people were pointing, so I looked, and yeah, everybody should have pointed, but maybe you were just waiting for me to go a little further. Okay, I'm not sure I was quite there. All right, so here's the point where x equals 1.5. And what's the y coordinate of that point? How are you going to find the y coordinate? Well, we could label some of these lines, and we've done this before, like, what's the Y value here? What's the Y value here? What's the Y value here? It's 2 everywhere on this line, isn't it? So this is a line Y equals 2. Make sure you lock this in. You don't want to go through the rest of the course not understanding what we mean by the line Y equals 2 or X equals 1.5. You keep stumbling over it. Get it out of the way now. It's not hard. But make sure you do it, just as you want to make sure, we want to, as we make sure you know where every point on these graphs go. Everybody's doing a good job of subdividing, your dotted lines all, I think, on almost every paper. I can't think of one where they don't look good. There's a scheme for locating the points. Make sure you know it. Okay, well, anyhow. So you've drawn the line Y equals 2. You've drawn the line Y equals 1. You don't have to label these if you don't need them, but that's Y equals 1/2 and that's Y equals 1/4, right? Okay. Now, what are we going to do about this point? Well, at this point, we want to draw a horizontal line. Passes through the point. Make sense? Okay. Now we're also allowed to draw some more lines, probably make them in a way that doesn't look exactly like the grid lines, but really, once you know where the grid lines are, you can draw lines anywhere you want to. Okay. How are we going to figure out what the coordinate is here? Well, one way is it's this far above 2, right? And this line is essentially a quarter of a unit above the y-axis. If a quarter is this big, actually it's closer to this big. That's a quarter, that's probably like 0.1, isn't it? Well, let's figure it out. It's in general. Go ahead and divide everything in half here. And we get y equals 3. And we want to subdivide that. Okay, we can do that. I should use a different color. So I'm going to kind of make that orange. So y equals 2.5 would probably be about here. And then y equals 2.25. Here, that's 2.25. So I'm going to say that looks like about, to one significant figure, that looks like about y equals 2.1, doesn't it? So be sure you understand every detail of this. Go back over this part of the video. If you don't, you can skip around till you find where I say what you really need to hear. Doesn't take that long. Video should be posted by this evening. I hope. Got a guy coming to look at an oil tank. It's got about 70 gallons of oil in it. He's bringing a couple of guys. If it's got 70 gallons of oil, it's going to weigh about 500 pounds, which means they're not going to be able to handle it. So I have to pick it up for them. If I have to pick it up for them, I'll be dead this evening and I won't get the video done. But other than that, okay. Okay. And I've got tennis elbow. I can't use this arm, so I have to pick up with one hand. Ridiculous. Those guys are going to feel so bad if they can't pick that thing up. That's reality. The video should be posted this evening, unless something intervenes. Okay. And if something intervenes, it's got something to do with that. But I don't think we're going to be able to get it, unless I can get the oil out. Okay. Back to here. X is 1.5, graph of X is approximately 2.1. Now, at this point, this is the first thing in the course where use of a calculator would be permissible, although you should be able to square 2.1 pretty easily. It's 4.41. You square 2.2, you get 2.84. Square 2.3, you get 5.29. So it's between 2.2 and 2.3. Actually, pretty close to 2 1/4. Okay. So this estimate was a little low because my graph wasn't the best. Your graph isn't going to be the best. You make an honest estimate off your graph, then you can check it with arithmetic and analysis and stuff. Okay. Now, f of x equals 3. This is an equation. Well, coincidentally, we already have the y equals 3 line here. And we can estimate with that point where the y equals 3 line meets the graph here. We've actually already done this. Most people got the 1.7 estimate. Some people said 1.75, which is actually closer. 1.732. This is an equation. It's got an equal sign. Okay, I'll know 1.7 squared is 2.89. 1.8 squared is 3.24. 1.89 is closer to 3 than 3.24 is. So 1.7 is a better estimate than 1.8. Okay. Okay, now in our last class, I'm pretty sure we labeled this point, maybe it's the first one. This point is one half, 1/4. Notice we haven't done any calculations at all in constructing these graphs. What is 1/1? What is 2/4? I don't really have room to label the origin. Well, I better. That comes out kind of nice with the first hand. This is negative 1/2. Fourth. This is 1/1. Or negative 1/1. This is negative 2/4. And now Let's flop down and grab that. And here's a red dot. Good parabola. Yeah, you can do this straight. Okay. So here it is. And we're gonna the x-axis here. And a y-axis here. It's still a 4x4 rectangle. Okay. Or actually, it is a rectangle. Actually, square. So I'm going to put another one here. Now I'm going to put another one over here. And then I'm going to put a couple more on. Up here. And I'm getting carried away so much. I'm going to do 3 now. Okay. Now, for this rectangle, for this square, y equals x squared. If I move the red dot here, no longer at the origin, is it? Still have nice parabola up here. Okay. Excuse me for a second. I want to go function notation here, and I want you to get used to it without having to worry about the way you put numbers into it. So that's easy. Okay. Y equals f equals x squared here. This one is going to be the function y equals g of x. And I'm going to pose a question, see if anybody can get it in a minute. Can you estimate these numbers for me? G of 4, G of 6, and G of 3. I recommend that you start estimating G of 4 by sketching the line x equals 4. Okay, hint. This would be the line y equals 2. How do you know that? Because this is a 4x4 rectangle, right? Or 4x4 square with a red dot in the middle of the lower edge. Okay. So right there's the line y equals 2. Where's the line x equals 2? Where's the line x equals 4? Where's the line x equals 6? Where's some of the other lines? So how How far is it from here to here? Show me with your fingers. Everybody. Hey. How far is it from here to here? Show me with your fingers. How big is this square? It's 4 by 4, right? So how far is it from here to here? 4 units. This is further than this. Okay. So if this is 4 units, what's the value of x at this point? Show me with your fingers. Yep. Yep. Your fingers. What do you think? Yeah. Well, out of this lesson, I come back to this part of the video. Really, one problem with the way math is taught when you get into coordinate systems and stuff is they give you a grid and tell you what all the numbers are. You don't have to think. You don't have to think about the numbers. You just write stuff down. You learn to do some stuff. You know, the whole idea of giving people a grid every time you want them to make a graph, I think people don't understand graphs as well as they would if you made them think. Okay, see, you're actually not used to thinking this way. So let's try to get used to doing it, because I think it's a foundation for understanding functions, for understanding graphs. I think when we get to doing the algebra and stuff, if you got this picture, if you understand these numbers, if you understand what the graph is telling you, you're going to understand everything a whole lot quicker and a whole lot better. Doesn't mean you won't stumble over some of the algebra, but you'll have the picture. Okay, so my point is that what did I do with a long piece of work? Okay. 2 units here, 2 units here, right? Which is a total of 4 units. So from here to here is 2 units. Okay. And from here to here, how long is that arrow? Show me with your fingers. Most of you aren't responding because you don't understand, or you're just tired. Like I'll be after I carry that oil tank. Okay. It's 4, right? All these squares are 4 by 4. They're all copies of the original one. Okay. So if it's 2 here and 4 here, how far is this? 6, right? Now, where is 4? Okay, now it took us a little while, but we finally established that, well, let's just put it in context. This line here is x equals 2. This line here is x equals 6. And the line x equals 4 is right here. Now my question, what are the following values? What's g of 4? This is your g of x function. G of 4 is going to be it's y equals g of 4, right? Because it's y equals g of x. Now what y value would you associate on this graph with the x equals 4 line? Not 0, 0 down here, 0 is way down here. It's not. What's the y coordinate of this point? Because this is the point where this line It's the red dot on this graph, right? The red dot on this graph is not at the origin because it's been moved. How far has it been moved? It's moved 4 units over this way, right? And how far has it been moved this way? Show me some figures. How many units? Okay. Yeah. A lot of different ways of representing it. But yeah, from here to here, you have to go over 4 units. Then you've got to go, well, it's 4 units up to here, isn't it? Because each square is 4 units, right? And 4 more units here, that's 8. So we get y equals 8 when x equals 4. So g of 4 equals 8. Okay. Now write down. You got it listed. Everybody's pretty much got this in that paper. Tell me what you think g of 6 is, and tell me what you think g of 3 is. G of 6 should be pretty straightforward. G of 3 might be a little more challenging, but you can at least estimate. Okay, so we're talking about the meaning of a graph and the things you have to understand graphs. We're not trying to do this without confusing it with a lot of arithmetic and algebra. Okay. Once you have the picture, then the arithmetic and algebra just fits everything together. It explains everything. So the one thing that people are not yet saying, and this is an important aspect of graphs, is this. I don't want to use f of x or g of x because that goes back to graphs that we're talking about right now. So I'm going to call it h of x. Y coordinate of the point on the h of x graph use my I got that far in my statement and realized it was going to work out the value of okay, for a function y equals h of x, the value of h of a is the coordinate of the point on the h of x graph. So that graph intersects the line x equals 8. Now, on a 1 to 5 scale, they don't have to hold up 2 hands. How much sense does that statement make right now? Okay. Now, let me draw a picture and see if it makes any more sense. Most of you are saying it doesn't make a lot of sense. Well, it's words. It's a lot of words. didn't really give you a whole lot of time to ponder and digest the words, did I? Okay, I want you to ponder and digest the words. Matter of fact, I might well assign you to be able to write the statement as a quiz next time. But maybe not. Let's see how we do this. So what it means is, okay, now, I want you to sketch a graph that looks something like that. It doesn't have to be exactly the same. And then I want you to draw a vertical dotted line that intersects the graph. Just about everybody now has drawn this graph. And I'm going to draw a dotted line. Vertical dotted line. Could be anywhere, as long as it intersects the graph. Once we put it on this side of the y-axis, that's fine. I just decided to be contrary, put it to the left. It could be anywhere. There's a dotted line. This line is now, your line is x equals a. So go ahead and label your line x equals a. Okay. Now, draw the line that will give you the y coordinate. You don't have a scale on the graph. Draw the line that will give you the y coordinate. Okay. Now, what's h of a? It's the y coordinate to the point where this vertical line meets the graph. Okay. Now, when I said draw the horizontal line that shows you the value of y, most people drew it through this point. Some people do it through different points. So you want to be sure you understand. This is the line that I can say is y equals h of a. And if you have a scale on the graph, you can estimate h of a. Make sure you understand this. Okay, go back and look at the video. It's near the end. It wouldn't be hard to find. Now, back here, you get a little head start. Okay, first of all, G of 4 is 8. Most people got G of 6. We intersect this curve with the line x equals 6. Where does it meet? I'd say tell me where it stops, and it stops right there. Okay. So this is the line y equals G of 6. And what's the y coordinate here? 4, 8, 12. Okay, this equals 12. It's top of a stack of 3 4x4 rectangles. So this is 12. Most people got that. Most people got the 12. On G of 3, the most common thing I saw was 10. Not bad. It's between 8 and 12. This thing is a straight line. If you had a straight line from here to here, it wouldn't. Here's the curve. Y x equals 3. Okay. And here's the point. This curve is an exact copy of this curve. It doesn't look like it, but assuming it is. On this curve, if you go 1 unit left, you go 1 unit up. Look at your y equals x squared graph. So if we go 1 unit left from here and 1 unit up, Y is 8 here, and X is 4. 1 unit left, X is 3, and Y is 9. This very short time where I can tell you there's a formula for this function. It's p of x equals x minus 4 squared plus 8. If you put 4 into this function, 4 minus 4 is 0, you get 8. Okay? Put 6 into this function. 6 minus 4 is 2. 2 squared is 4, and you add 4 to 8, you get 12. You don't understand this, okay, but if you do, it's really good. If you put 3 in here, 3 minus 4 is negative 1. Square negative 1, you get 1. 1 and 8 is 9. So now, if we put a copy of this function any place in the xy plane, we're going to know what its formula is. Okay? That's a big deal. It's something that almost nobody ever understands, even though you get rules for doing it in a pre-calculus course. And it's a big deal because it can be very helpful in lots and lots of places. So we're heading for that. You're not responsible for knowing that. I'm telling you that, and that's kind of where we're going to pick up. I'll probably ask you a few problems, few questions regarding this picture, okay?